Okay, day 2, change in tandem. So we're just kind of going back through, we're reviewing a lot of the characteristics that we talked about in Unit 0, okay? We needed a really good foundation, all right? So we have already talked about how to identify and write intervals. Intervals of increase, intervals of decrease, constant intervals, and then positive and negative intervals, okay? Positive is anything that is above the x-axis, and negative is anything that is below the x-axis. So positive right here lies above, and negative lies below the x-axis. And I do want to make a note right here that the x-axis is neither positive or negative. That is neutral, okay? Positive and negative, above or below the x-axis. All right? Now, when we are writing intervals, okay, don't forget that we write these from left to right, and we write all intervals according to their what values? Their x values. Perfect. Okay? All right, interval notation. This is where I use brackets or parentheses, or we might have a combination of the two. Okay? Also, just a reminder, we will only always have a negative infinity on the left and a positive infinity on the right-hand side, because we write everything from least to greatest. Our inequality notation, we have less than, greater than, less than or equal to, greater than or equal to. And that's typically, we use our x's for domain and our y's for range. So it might look something like that, where I've got numbers on either side or infinities, okay? Or something like that, that's fine. So we use our x to write domain or intervals. And we use y for ranges. Okay. All right. A very quick review of writing intervals of increase, decrease, and constant, okay? We are asked to highlight anything that is increasing with green. This graph increases from here to here. It's going up from left to right. We are asked to highlight anything that is decreasing in red. My graph is decreasing from the left until I get here to this point where it turns to go up. And it also decreases again on the right-hand side. And this graph is constant right here. Interval. Okay, I typically like to write everything in interval notation in pre-calc and on, okay? But if something is given in inequality, I just need you to be able to read it, okay? All right, now, remember, we write these according to our x values. So I'm going from left to right, okay? So I am going to write my intervals from negative infinity to positive infinity. And I am marking on the x-axis where changes happen, okay? Right here, from left to right, there is a change that occurs right here, but I'm marking the x-axis because I write it according to my x values. Then a change occurs up here, but that happens at 2. Another change of direction happens here. and then it doesn't change directions again, okay? So I'm going to write down negative infinity, 0, 2, 5, and then positive infinity. This just helps me write my intervals like my starting, stopping places, okay? I found that this helps like 2 or 3 years ago with my pre-calc kids, just me writing my different intervals using this notation, okay? All right, now, at first my graph decreases, then it turns and goes up, then it's flat, and then it goes down, okay? Now, the reason why I write it this way is because, especially because the graph on the right side is going down, everybody always wants to finish this off with a negative infinity because it's going down. Okay, but remember, I'm moving from left to right, and as I move through time, I'm going towards positive infinity. So my graph decreases from negative infinity until I get to 0. Then it increases from 0 to 2. From 2 to 5, it is constant. And then from 5 to infinity, it's decreasing again. Okay? Now, before I answer domain and range, okay, I want to make a note right here, and I want to connect this to part F. My question here is, what thoughts do you have about the intervals as stated above, the way that I wrote them? Did you use brackets for closed included points or parentheses for for open or non-included points? Why or why not? What did I use for everything? I used parentheses. Now I want to talk about why. So, right here, the point at which the direction changes is just that. It's a point, right? And a point is a single location in space. Is a point increasing or decreasing or constant? No, it's just telling me a location. So that specific location we don't need to include because it's not going anywhere, okay? So I'm going to say parentheses for intervals, and then I'm going to explain why. A point / location is neither or neither, however you want to say it, increasing, decreasing, or constant. So I use parentheses for all intervals. Okay? All right, let's go back to D and E where I'm asked to identify the domain and range. Now, on domain and range, okay, for both of those, I am looking, are there arrows? Are there any holes? Are there any asymptotes? Okay? Now, I am graphing. There's an arrow pointing to the left. That indicates it keeps going. And I'm tracing my graph. Are there any holes or asymptotes where I have to pick up my pencil and move elsewhere? No. So that means that all real numbers or negative infinity to positive infinity is my range. I'm sorry, my domain. Thank you. I was looking at the next thing that I had to do and I said the wrong thing. I'm sorry. Okay? All right. The range. Once again, I'm looking at these arrows. Okay, those arrows are pointing up and down. As I am reading this graph from bottom to top, are there any holes or asymptotes where there is a full-on break in my graph? No. So once again, all real numbers or negative infinity to positive infinity. Okay? All right. Questions so far? Everything so far with the exception of the B value in my transformations, everything has been reviewed. Okay? My B value is new. This is all review. Are y'all good so far? Okay. Now let's take a look at the next page. This is new. Okay? This is new. All right. Some vocabulary. A point of inflection. A point of inflection is where a curve changes from concave upward to concave downward, or vice versa, down to up, up to down. Either way is fine, okay? Y'all have seen things that are concave. For example, a contact lens, okay? A microscope lens, things like that, okay? And whether it's concave up or concave down kind of affects whether it zooms in or zooms out, okay? So right here, this is what concave up looks like. It's kind of like a parabola opening up, and concave down is an upside down parabola type shape. Now, in my notes right here, I say that my slope is increasing. Here's why. Okay, here's some vocabulary from geometry. Do you see all these points right here? You can draw what we call a tangent line. Do y'all remember the tangent line that just like bumped up and hit the circle one time? Okay, we can draw all these tangent lines up against this parabola. At first, my slope is negative. Now, when I get right here to what I would kind of consider a vertex or a maximum or a minimum, here this would be a minimum, if I draw a tangent line, my slope is 0 because it's flat. But then as I move to the right, it just gets more and more positive, much steeper, okay? So right here, this graph is increasing. Over time, it is increasing in this interval. Similarly, right here, this one that is concave down, I can draw these tangent lines, okay? So this one initially has a positive slope. Then I get here to this maximum, and the slope is 0. And then what happens to my tangent line slopes right here? Yeah, they get more and more negative. They get steeper. Okay, so therefore I can say that my slope is decreasing. Just like a linear function rises from left to right and it's increasing, decreasing falls from left to right. Okay? Now, while there is a more specific way of finding a point of inflection, we do abbreviate that a POI. In calculus, in pre-calculus, we're just going to estimate, okay? We're just going to estimate the point of inflection by finding the average of the x values and the average of the y values. It's kind of like finding a midpoint, okay? So in pre-calculus, we're not finding it exactly. Okay, we're not finding it the calculus way, okay, the more appropriate way, but we can estimate it. And it's kind of finding the average of those highs and lows, okay? Okay, now before I follow all of these directions, I'm going to skip down here, okay? My directions here say use the graph of g of x shown at the right to determine the intervals of concavity. I'll do that in a moment. And state the points of inflection. Now, remember, the points of inflection, it's like finding the average of your x's and your y's of your maxes and your mins. Now, this is a minimum. and this is a maximum, right? About halfway between, this is a point of inflection. Do you agree that this is kind of like the halfway point where it's opening up, but then you start kind of looking at it as opening down? Okay? And then it very quickly up here, it's opening down, but then it curves and it opens up. This right here is my point of inflection for this one. Okay? So I'm going to state that my points of inflection are the ordered pairs negative 0.5, negative 3, and we have the ordered pair 3, 1. Does that kind of make sense why those are my points of inflection? You just kind of look at it and estimate it, yeah. Okay? Now, right here, when I am writing intervals, okay, when I am writing intervals of anything, what values do I use? Intervals, what values do I use? X values, okay? So my X values, once again, I'm working from the left to the right. I'm going to make a note right here that we use X values to write intervals even intervals of concavity. Okay, we are going to use the X values of our points of inflection. I'm going to say of our POIs. Okay? We use X values to write intervals, even intervals of concavity. So I will use the X values of my points of inflection. So I'm going to mark those values right here. Okay? That's also the same thing as what sits in the front. And while I do my intervals, I'm going to do these kind of the same way I did before. Okay? From left to right, I'm coming from negative infinity, and I go to negative 0.5, and then there's a change. I keep going, and then at 3, there's another change, and then I keep on going to infinity. There were only 2 points of inflection here. Okay? From left to right, I'm starting and my graph opens up, so that means it's concave up. Then it turns and it is concave down. And then it turns one last time and it's concave up. Okay? So I'm going to use these numbers right here to help me write my points of concavity. Right here, it is concave up from negative infinity to negative 0.5 and from 3 to infinity. Where is it concave down? Negative 0.5 to 3. That's why when I write intervals, okay, when I write intervals, I might be asked to find intervals of increase, decrease, constant. I might be asked intervals of concavity. I might be asked to find a lot of different types of intervals in one graph. So that's why I kind of write down my important points and I draw shapes in there, because to me that is a visual. I am a visual learner, okay? You found out what kind of learner you were at the beginning of the year, okay? So I'm trying to give you lots of different ways. Yes, sir?
So in calculus, when you do it in like a specific way, will it still be like the
It's still going to be very, very close. if not the same.
Decimals with it?
Yep. Okay? All right. Very quickly, let's talk x-intercepts and y-intercepts. This is review, okay? So I threw some new stuff in there. We're going to let it sit for a little bit, okay? We're going to let it marinate. Y'all sit up for me, please, okay? I'm tired too. Y'all don't make me jealous, okay? An x-intercept is where the graph, if it does at all, crosses the x-axis, okay? That they are the solutions, the roots, the zeros, and that happens when f of x is set equal to 0, okay? Well, don't forget that f of x represents y. So right here, my y value is 0. Now my y-intercepts are when x is 0, okay? So right here, my function notation, I just plug in 0 into the function and work it out. So I'm plugging in 0, working it out, and I get whatever my y-intercept is, okay? Whatever you're trying to find, you plug 0 in for the opposite thing, okay? So we're going to look at a graph and an equation and find the x and the y-intercepts. The graphs are the easiest because you can look at it and pick it out for the most part, okay? So I'm going to go mark my x-intercepts. Okay? I see that graph cross the x-axis 3 times. That happens at the following ordered pairs. We got -3, 0. What else? Okay? And 4, 0. Perfect. Okay? Now, what about my y-intercept here? Where is that crossing the y-axis? At -3, so how do I write that? Perfect. Hey, there's more than just Keaton in here, friends. I appreciate that he's talking to me, but y'all can talk to me too. Even if you get it wrong, I'm not going to be mad at you. Okay? All right? All right. The graph is easy when it crosses over pretty places. Okay? Let's take a look at an algebraic function. Okay? When I'm trying to find my x-intercepts, I want to take my function and set the whole thing equal to 0. All right? I have 4 terms right here. In order to solve something that has 4 terms, I'm going to factor by grouping. We want to factor by grouping. Make sure that you're zoned in and paying attention, okay? So that means I'm going to group the first 2 terms and the last 2 terms if they're in standard form. And I want to identify my GCF. Somebody other than Keaton, talk to me. What can I remove from this first set? X squared, yep. So when I take that out to the front, I'm left with perfect. Now the goal is to make it look the same in the second set. I also notice right here I have a negative leading coefficient, which I do not want, okay? So I'm going to divide out a -4. What does that leave me with? Yeah, x minus 3. Now, both of these terms now have the same factor. So you can take that out to the front and take your GCFs and write that in its own set of parentheses. Okay? Well, this right here, my friends, is not completely factored because this is a difference of squares. That can continue factoring. How does that factor? X minus 2, x plus 2. A plus in one, a minus in the other. And this is where we take every single linear factor and we set it equal to 0 and we find our solutions. Uh-oh, that should be x minus 2. I'm sorry. Okay, so what do I get for my solution, y'all? 3, 2, and negative 2. And yes, I do want to write those as ordered pairs. So I'm going to come right here and I'm going to say my x-intercepts are 3, 0, 2, 0, and negative 2, 0. Okay? I also want to identify my y-intercept here. This is where, friends, you take 0 and you plug it into the function, your original function. If you plug in 0, what's 0 cubed?
0.
What's negative 3 times 0 squared?
0.
What's negative 4 times 0?
0.
So all you're left with is that constant back there in the back. So that's your y-intercept. Okay? All right. Whew. What if I'm given a situation and I'm asked to model it? Okay? Tina is a sales clerk at Electronics Depot who earns $325 base pay plus $18 for each item sold. Express her gross salary G as a function of the number X of items sold. Find her gross pay if she sells 24 items. First thing I'm asked to do is to write a function as G of X. What do you know she gets no matter what? 325. Now that amount does not change, correct? Now what does she get on top of that? $18 per item that she sells. Okay, so there is the function that represents her salary. Now I'm asked to find her gross pay if she sells 24 items. So that's where I simply plug in 24. Some of you might have calculators lying around, okay? If you don't have a calculator lying around, you are welcome to get one. Not all of them are alive, but you can use one. Okay, I'm going to take mine out. It has yucky fingerprints from my children, okay? They think that this is a fun toy. Okay, I've got 325 plus 18 times 24. That gives me $757. Okay, so if I was asked, friends, if this was part of a free response and you were asked to write out what this means, what would I say? If she sells
24 items, she would get, or her gross pay would be $757.
perfect. Simple as that. And I would use their terminology, whatever is used in the problem, okay? Now, I realize you're not taking my AP exam, okay? But if you were, that's how you would do it, okay? All right, now, next. If your pre-calculus book is dropped or thrown from a height of 45 feet on the planet Newton, you see what we did there?
No. It's okay. You know.
If I'm throwing something, it's going to hit the ground, right? That's the law of gravity. Isaac Newton.
It wasn't that.
Yeah.
It could have been.
Oh, come on. I feel like if you throw it, it makes it more funny. Okay? All right, here we go. All right, its height in feet after t seconds is approximately h of t equals 45 minus 14t squared. This is my function that represents the height. Now the question is, how long does it take? So I'm looking for time, which is t. How long does it take for the book to hit the surface of the planet? Now, what do you know about the height of the surface? It's 0 feet above the ground. Okay? So I am going to take my function and I am going to set the entire function equal to 0. And my job is to solve for t. I'm asking how long, okay? Be mindful of what we're going to get for our final answer or answers, okay? The first thing I'm going to do, I'm going to move this negative 14t over to the left side. That makes that a positive 14t squared. And then what do I do next? I divide both sides by 14. So 45 divided by 14. I'm going to round. We need 3 decimal places in pre-calculus, okay? Unless you're told otherwise. 3.214. Okay? And then how do I solve for t? Okay? If I take the square root of both sides, now this is me applying the square root. I have a rule that I have to put a plus or minus out in front of anything I apply the square root to. Now, if the square root is already there, you don't do a plus or minus. Yes. If I have a square and I draw the square root, you have to do plus or minus. Okay? But if the square root were already there, no plus or minus. Okay? Now, when I take the square root of both sides, I get plus or minus 1.793 seconds. But I have a question. Can it hit the ground in negative 1.793 seconds? No. I'm going to make a note right here that I have no negative time. Okay? In the context of the problem, I'm not going back in time. So I am going to be specific. I'm going to say it takes approximately 1.793 seconds to hit the surface. Notice once again, okay? Yeah, I know that, y'all. I'm using their terminology. All right, finishing up on this last page of notes right here. I need us for us to have a pink and yellow highlighter, okay? Pink and yellow, just because these contrast pretty well, okay? For my graph right here, I'm going to highlight the graph of f of x. I'm going to highlight the whole thing yellow. Y'all hush and let's go. Okay, I'm going to highlight the whole thing yellow, and actually I'm going to continue this off to the right hand side, and I'll show you why in a moment. Okay. Everywhere that it says f of x down here in my problems, I'm going to highlight f of x because I need that to be a visual standout for me. Okay. And then everything g of x, I'm going to make pink. Okay. Now, as I am highlighting these, I am noticing that these graphs cross over each other. One is above or below the other at any given time. Okay. I can see graphs are falling and rising, and one of them has a little flat part. Okay. I'm just kind of noticing all the characteristics that I have been talking about. So I made f of x, and everything that was labeled f of x, I made it yellow. And then right here, everything that was g of x, I made pink. Whatever colors you use, that's totally fine. Okay, it just needs to be kind of a stark contrast. Okay? All right. So I'm going to answer these questions about each one or both of the graphs combined, okay? First of all, I'm asked to identify the domain for both of my functions. Now, I'm looking at the yellow function, okay? I see that there's an arrow right here. I'm tracing the graph. There's no break at all. So my domain of f of x is negative infinity to positive infinity. What would I say for g of x? Same thing. Negative infinity to positive infinity. Okay. And then for this one, it asked me find the values of x such that f of x equals 0 and g of x equals 0. If I'm asked to find the values of x where my y values are equal to 0, I'm going to make a note here that this is asking for the x-intercepts. Okay? This is asking for the x-intercepts. Okay? And those x-intercepts for graph f of x, that would be negative 4, 0, 2, 0, and I want you to take a look, okay? Even though I do not see this graph crossing, does everybody agree that right here this graph is going to continue and continue and continue, and it's eventually going to cross again, okay? So what I need to do, I need to look at this line segment, and I need to figure out what the slope is so that I can continue my graph. So I'm trying to find a pretty grid where it crosses. So here I'm going down 2 and over 3. So I'm going to keep going down 2 over 3, down 2, and then I'm going to go over 3 units. So I'm extending my x-axis, and I am going to continue this line. Whoop. So what is that last x-intercept? 15. 15, 0. Just because you do not see it on the picture does not mean it's not there, okay? All right, what about g of x? Somebody other than Keaton, please. Negative 2, 0, just because 5, 0. 7, 0. Okay, now, does this graph ever turn to come back down and hit the x-axis again? No. All right, what you got, Keaton?
On a test or something, we have to keep going?
You would need to know. Yep. All right. Now, let's keep going. It says find the values of x such that f of x equals g of x. All right, where are they equal to each other? What's happening when they're equal? They're crossing each other, okay? And we call this an intersection. Okay? We're finding the intersections. Now, I'm looking for the x values, and I'm going to just estimate that one, okay? There are 3 places. So I'm going to say x equals negative 3. Where else? X equals positive 3. And what's the last one? 9. X equals negative 3, positive 3, and 9. It only asked for the x values. Okay? All right. Then, this says the values of x such that f of x is greater than g of x. So if something is greater, I'm looking for where it is above. Okay? So I want to find all the places where my f of x, my yellow function, is above my pink function. This is going to be an interval. So I look from left to right. Now remember, I'm going from negative infinity to positive infinity. So it starts out above. Do you agree? So I'm going to say that it goes from negative infinity until I get here, and that's where they meet. So if this is where they meet, okay, where they meet, they are equal, correct? So it is not included. So I'm going to use parentheses. Then it's below. Then I come back right here where they meet, and that happens at 3, not included, until I get to 9. Does it ever go above it again? No. Okay? All right, let's look at letter F. Okay? Letter F. I want to find the values of x such that g of x is greater than 0. So right here, I'm looking for where my pink graph is above the x-axis. This is where it's positive. Okay? Where is it positive? So I'm tracing my pink graph right here. Is it positive right now? Oh shoot, I'm sorry. Is it positive right here? No. Is it positive right here? No, that's where it hits the x-axis, right? It's 0 right there. Is it positive beyond that? Yes, it's above. Okay? So from 2, I'm sorry, yep, from negative 2 until I get to 5. Both of those not included. Then it dips back down, and then again at 7, it goes above. Does it ever come back down? No. So from 7 to infinity, this graph is positive. Thank you so much.
You're very welcome.
Okay? All right. Let's look at H. I want to find the values of x such that f of x increases. That's where my yellow graph is going up. Okay? I want to find it where my yellow graph is going up. So I'm tracing my yellow graph from left to right. What's happening? It's going down until I get, we're just going to estimate this right here, until I get here to this turning point. And then it goes up. What value does that happen at? From negative 1, it's going up, 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 up until I get here, and then it goes flat. Okay, where does this happen? 3.5. Do you kind of see where I'm going with having to be careful with picking out my characteristics? Okay? All right, I want you and your seat partners to do E, G, I, K, J, L. Okay? I want y'all to work on that. I'm going to press pause on the video, and then we will check those in a moment. Check your answers, make any corrections that you need. Okay, I went into my work right here. I gave the x-axis another color just so that there was a visual split there for the zeros above or below the x-axis. You just have to be very careful how you read it, okay? Attention to detail is going to get us in pre-calc, okay? But I believe in you. You have to believe in you.
How
All
much
right.
paper do we have to do?
Do what, babe? I would say 1 through 12 needs to be done when you come into class tomorrow, just so that you have that under your belt, okay?